morning, everyone. So we are almost done with chapter 3. Our next section is supposed to be 3.5, but we're going to skip that for now and we're going to go to 3.6. So in your pink packet, I am on page 51, and that's where I'd like for you to go. So the thing that we're going to be talking about today is solving radicals and solving equations that have exponents in them. But more specifically, our exponents are going to be fractions, okay? So a couple things to keep in mind. As we solve, we're going to have something new in this chapter called extraneous solutions. And, you can read here what it says. But basically, as we solve a problem, we're going to get answers. And sometimes you're going to get an answer that even if we solve for it, if you plug it back into the original equation, you're not going to get the left side to equal the right side. So that's called an extraneous solution. It's a solution as we work through the problem, but when we put it back in, it doesn't make the left side equal the right side. The only time for us that you really have to worry about that is when you are solving with the square root, some type of even root, square root, fourth root, because you can't take the square root or the fourth root or the sixth root, say, of a negative number. So that's really where we have to be careful. So the other thing, the way these problems are set up is you're going to see problems, kind of like in before, where the x shows up once. So it's a one variable occurrence. So everything on this page, on page 51, the x shows up once. But when we flip the page, you're going to see the x's show up a multiple of times, so usually twice. And how you solve those will be a little different than the front side. So what we're going to do is like these two problems together, and then when we come back as a class, we'll do these extra problems. All right, so when there is just one x showing up in these problems, you're just going to isolate x. That we've been doing that since middle school, which means we just work backwards in the order of operations. And I'm going to write those down, and you should make that little list because that's the list to go through to get x by itself. So the first thing I'm going to do to get x by itself is move my addition subtraction, and I won't move this 3. Because that's stuck inside the square root. So instead I'm going to move this 3 and I'm going to subtract 3. So this first problem I'll show more of the basic steps. So those cancel out, and then I'm left with x minus 3 equals 1. So then I look for multiplying or dividing to get rid of over here, which there isn't any. This is the square root of x minus 3. I never said times or divide. So now what I'm going to do is get rid of the square root. And to get rid of the square root, I'll use its exponent counterpart, which is a square, something to the second power. So what I'll do is square the left side, and then I'll square the right side. So when I square the left side, that little square cancels out. That x minus 3, they undo each other because they're inverses. So I'm just left with x minus 3. And when I square 1, just 1 times 1, that's 1. And now to get x by itself, I'll just finish it up. It's kind of like that was in parentheses. I'll just add 3 to the other side, and when I'm done, I get 4. So we're going to check for an extraneous solution after we do the second one. So on the second one, same thing. I'm going to write my steps of getting x alone. And the first thing I want to move is the addition subtraction. So I'm going to subtract the 3 over. Here, I'm not going to show those little steps anymore. That gives me negative 2. Then I'll move the multiplying and dividing. This is 2 times the square root of x, so I'll move this 2 by dividing. And that leaves me with the negative 1. And now to get rid of that square root, again, I'll use its exponent counterpart, which is a square. So I square the left side and the right side. So again, that squared cancels out that little check mark, that square root, so we get an x. And then negative 1 squared. So in the last video that I made, I said anytime you want to take a number to a power on your calculator, you have to put it in parentheses. So parentheses, negative 1, close your parentheses, squared. Or just do it in your head. Negative 1 times negative 1, or type out negative 1 times negative 1 on your calculator, because you should get 1. And if you don't put it into the calculator correctly, it will give you negative 1. So at this point, there's my answer. So what is an extraneous solution? So an extraneous solution just means I'm going to go back to my problem, and I'm going to put 4 in here, and I should, after I do the math, get the left side to equal the right side. So for sake of time, I'm just going to put this in my calculator. So when I do that, I've got both calculators here, so I've got the new operating system and the older operating system. And let me show you on the newer operating system first. So I'm just going to focus on the left side because I want to see if I can get 4. So I just do 3 plus, hit my square root, and instead of x, I'll put the 4 in there. And I'll arrow out of that square root, and I should get 4. So how am I going to get 4? Well, the calculator is going to do the square root first. It will do 4 minus 3, which is 1, and then the square root of 1 is 1. And it's going to take that 1 and add the 3, so we get 4. So the left side equals the right side. 4 is a solution. It's not an extraneous solution. If you're in the older operating system, then when you type it in, when you hit that square root button, the parentheses will start. So you'll have to close the parentheses so that your calculator knows that all of 4 minus 3 is part of that square root. And there's that 4 again. The other way is 2 square root of x plus 3. So again, I'll just put that in. So 2, hit my square root button, 3, no, I put a 1 in, sorry. Arrow out, so it's only the square root of 1, or close your parentheses on the other operating system, and then I'll do plus 3. So what's going to happen is, in order of operations, it's going to do this radical first. Square root of 1 is 1. 1 times 2 is, let's see, 1 times 2 is 2. 2 plus 3 is 5. So, as it turns out, this is an extraneous solution. So what would happen is, like, if this were a multiple choice test, you wouldn't see 1 in there. It would probably just say no solution. It's not going to say x equals 1 is an extraneous solution. It just wouldn't even count it. Okay? All right. Below, before we move to the next problems, you're going to see these graphs. And so the idea is that you can check your problems graphically to see if 1 is a solution or an extraneous solution. So what I've done is, I'm on the older operating system, is I've gone to my y equals and I put the left side in for 1. You could think of this as a system of equations. And I put the other side into another y. And then I hit zoom 6 and I graphed it. So remember, 1 is this horizontal line. This is just every y coordinate here is 1. And then this other side, the 2 square root of x plus 3, that's a square root shape. So remember, square root shape starts at a certain point and then it keeps going. So this shape is actually starting about here and then it keeps going. So what's going to happen is these two never meet. And that means there's never a value that they're going to have in common. So that's why we got an extraneous solution. Even though we did the math and we got 1, it's considered an extraneous solution. So you can see that visually as well through the graphing calculator. You would just put one side into y1, one side into y2, and look for them to meet. And then if you want to know where they meet, if that was an option, I would just choose that option 5, intersect. All right, we're going to be doing this third one back together as a class. So let's jump down to this one. So here we have exponents that we need to get rid of. And so the easiest way to get rid of the exponent is to, have it cancel out. So first, when you look at this exponent, and I'm going to write in these graphs because I don't need that space, this is 2/3. And there's one exponent that they never write. It's just assumed that it's there, and that's the first power. So even behind this x, there's a little 1 that we don't see. So what I want to do is to get rid of this exponent by making it worth 1, because anything to the first power, you still have what you started out with. 7 to the first power, I still have 7. X minus 5 to the first power, I still have x minus 5. So what I have to do is get this exponent and multiply it with another exponent so that I get 1 when I'm done. And the easiest way to do that is just the reciprocal of the exponent. Because then what happens is I get 6 over 6, and 6 over 6 is 1. So to get rid of the exponent, that is a fraction, you will use the reciprocal of that exponent. All right? So anyway, we still have one type of x, and I'm still going to make this checklist. And now I'm going to start to get x alone. So first I'm going to add the 1 over. And that gives me 12. And then I'm going to move my multiplying and dividing. It's 3 times all of this, so I'll move the 3 by dividing. And when I divide by 3 here, I get 4. So now what I want to do is get rid of this 2/3 power. So what I'll do is take this whole side to the 3/2 power. And I really don't have that much room here. I didn't plan that out very well. but I'm going to take this to the 3/2 power, and that means I'm going to take the 4 to the 3/2 power as well. So what happens is this 2/3 to the 3/2 power, these are exponents that are going to multiply to each other. They become 6/6, like I talked about up here, which is just 1. And again, they don't typically write the first power, so it just becomes x minus 5. So this 4 to the 3/2 power, so this is just a reminder of what we talked about. This can be written as a radical. And remember, the denominator becomes that little index number, and the numerator becomes the exponent. So what happens is I'll be taking the square root of 4, which is 2, and then I'll take that 2 to the 3rd power, so 2 times 2 times 2, and I'm going to get 8. Now, we do have our calculator, so you could always just type this in. I would recommend you just type in 4 to the 3/2 power. So again, on the newer calculator, it's just going to raise that exponent for you. Let me hit that so you don't see that light. And I'll just put in the 3/2 power like this. On the older operating system, once you hit that exponent button for exponent, you have to put that exponent in parentheses so it knows that's the whole exponent. But either way, you're going to get 8. Okay, but you can do it without the calculator. You just have to remember where this goes as far as a radical is written. So anyway, I get 8. And now I'm going to add 5. And when I'm done, I get 13. We'll talk about, do we have to worry about, is this an extraneous solution or not? But let's finish the next one. So go to the next one. Again, I'm going to make my little checklist. Add, subtract, multiply, divide, exponent. Okay, so the first thing I'm going to get rid of is my adding, subtracting. I'm going to add 7. Or add 1 to get 7, sorry. And now I want to get rid of the 3/2 power. So again, if this is a 3/2 power, I will use its reciprocal of 2/3, and then that would become 6/6 and get 1. So that's what I want to make as my new exponent to get rid of the 3/2. So 2/3 and then 2/3 on the other side. So again, this becomes an exponent of 6/6, 6/6, which is 1. And then what I'm left with is just x plus 2 to the 1st power, which is x plus 2. So here, if you want to try, the same thing that I did here, I'm going to put it up here. Here's the 7. Remember, the denominator is the little index number, and the numerator is the exponent. And the cubed root of 7, I don't know that. And then since I don't know that, I don't know what it is going to be squared. So this is one where we're going to type it into our calculator. And again, this is tough to type in. This is much easier to type in. So using the old operating system, I'm just going to do 7, hit my exponent key. I have to wrap it in parentheses, and I'm going to type in the 2/3 power. And I get this decimal. So, it's kind of hard to see. We're going to go 3 decimals. So 0.659 is how I'm going to write this number down. 3.659. And remember, this is us rounding, or I guess truncating, whatever you want to call it. And now I'm going to subtract the 2. And when I'm done, I get 1.659. The other way you could write the answer is you could actually just leave it as 7 to the 2/3 and write it as 7 to the 2/3 subtracting 2, and then you get your answer. I like the decimal one better, but this is technically more accurate. But yeah, so it's up to you. So when do I have to check for an extraneous solution? So this problem in its original format is not a square root problem, because remember, this 2/3, if you rewrite it as an exponent, the denominator is the index and the numerator is the exponent. So this is a cube root, and cube roots are fine. We don't have to worry about extraneous solutions. But in this problem, if I were to rewrite this as a radical, again, that little denominator is the index number, and the 3 is the exponent. So ignore what's in red. And this is a square root. So I will just want to see if 1.659-ish will get me to 6. So this one I am going to type in the calculator, and I'm just going to type in the decimal and realize because I did not use the full decimal, I won't get 6, but I should get close to 6. So again, I'm just going to type this in. So start my parentheses. I'll put 1.659 plus 2. Hit my exponent button. I'll put in my 2/3 power. I'm going to arrow over, and then I'm going to do minus 1. And do I get the 6? Whoops, I didn't type that incorrect. I just realized that. Hold on. I should have done, I switched my exponent around. So 1.659 plus 2. It should have been the 3/2. Wasn't looking. Okay, then minus 1. Do we get 6-ish? Sorry. And I do. 5.999. That's pretty close to 6. So this works. It is not an extraneous solution. So this is an answer that works. And again, the other thing I could do is put this into y1, put this into y2, and see, do they meet? Would my x value be about 1.659? And you would see that it is. All right, last problem. So on these problems, we have more than one type of x. So, and actually looking at it, I think we're only going to do one together and do the other two in class, just for the sake of time and stuff. So we're going to do the middle one. Oh, do I want to do the middle one first? No, let's do the bottom one first, I think. Okay, I paused. After careful consideration, we're going to do the top one together. So they're not all going to be this difficult. I was kind of looking at them. And so, yeah, so don't be freaking out. Some of them will be a little bit easier than what were picked for these notes. So with more than one type of x, what we're going to have to do when solving a radical equation with multiple variables, so an x here, an x here, what we're going to have to do is isolate the radical, and then we're going to start to use inverse operations. So in this case, my radical is already isolated. In the one below, it's not isolated, so I would want to move the one over. So that's the key thing, is isolating the radical. What we need to do is somehow get to that square root. So where I talked about, doing the order of operations backwards, it's not quite the same here. So what I want to do is I want to get to this x plus 2 so I can start moving stuff around. So I have to undo that radical. So after you isolate the radical, you'll want to then get rid of the radical. So since it's already isolated, the first thing I'm going to do is get rid of it. So isolate the radical and then get rid of the radical. So since it's a square root, I'm going to square this side, and then I'm going to square this side. But I got to square it all, so I got to want to remember that that's squared in parentheses. So what happens is this squared, again, cancels out that x plus 2, or the square root, sorry. So I'm just left with x plus 2. And then this squared actually means, from last chapter, that there are 2 of these. And this is a neighbor meets the neighbor situation. So I'm going to quickly multiply those out, and then we'll talk about what we do from there. So when neighbors start to meet, I'm going to get 16, and then I'm going to get a negative 4x. But when this neighbor comes in, I'm going to get another negative 4x, which together make negative 8x. And then when these neighbors meet, I get x squared. So I still have the x plus 2. And now what we're doing is we're going back to chapter 2, and I'm going to realize, well, hey, there's more than one type of x. And when there's more than one type of x, our goal is going to be to factor, or try to factor. So what I want to do is get it into standard form. I want x squared to be first, and I want it to be positive. And I want ax squared plus bx plus c, and I want it to equal 0. So what I'm going to do is move the x to join this minus 8x. And I'm going to move this 2 to join the 16. And when I write it, I'm going to have it in standard form, so that means the x squared is going to go first. So when I move those things over, it's going to be 0. This will be going first. So when I subtract x from here, and it's gone, and I subtract x from here, negative 8x minus an x is a minus 9x. And then when I subtract the 2 here, and I subtract the 2 here, that's going to become 14. And now this is in standard form, and we're going to have to factor. And I guarantee you're going to have a problem like this on your chapter test. Okay, so I'm going to make my x. So I need factors of 14 that get me to the negative 9. And that's going to be a negative 2 and a negative 7. Notice I'm filling in all of this with x's. And now I'm going to go to my parentheses. And x is meeting x to make x squared. And now I'm going to draw a loop, and I'm going to draw a loop to try to get these numbers. So x times what can make this minus 2x is a minus 2. And then x times what can make this, that's a minus 7. And then it's simple about just what makes these equal 0. So I get 2 answers, 7 and 2. So what I want to do now is see, are these the answers? So again, there's two ways you can do it. One is you can put 7 in the left side, 7 in the right side, and see if they meet. The other way you can do it is put 2 in, and you get the left side to equal the right side. So that's what I'm going to try. Well, yeah, let's go ahead and try that. So let me get a different calculator. So putting this problem in, so starting at the left side, I'm going to put 7 in, and you could probably do this in your head just as fast. So 7 plus 2, the square root of that, well, that's going to be 3. And if I put 7 into this side for take away 7, I get negative 3. So the left side's not equaling the right side. This is considered an extraneous solution. So it's really not a solution. So now I'm going to do the same thing and put 2 in. So on the left side, 2 plus 2, which you should hopefully realize the square root of 4 is 2. And if I put 2 in this side for take away 2, I get 2. So the left side equals the right side. So technically, this is the only solution that works. That's it for the video notes. We're going to pick up in class and do the other problems.